So I'm looking at this integrand, I'm looking at the function here, and I'm asking myself, is there any part of this function that I can differentiate and get another part of the function? So I see here that I have 2x squared, and I know if I differentiate that, I will be left with, well, I'll be left with 4x, but I'll be left with an x to the first power, and that's kind of what I'm looking at. So I'm going to go over to the side here, and I'm going to set u equal to 2x squared, and then I'm going to differentiate that with respect to x on both sides. So I get du over dx is equal to 4x. Or, and then I multiply both sides by dx. Not technically accurate, but that's kind of what I'm doing. And I get du is equal to 4x dx. And now I'm getting a little bit excited because I see that I have x dx, and here I have x dx as well. So what I'm going to do is I'm going to divide both sides by 4 on this, and I'm going to get 1/4 du is equal to x dx. Now I could kind of rewrite this if I wanted to. After you do this a few times, you won't have to, but I can rewrite this as no, come on, let's do it right. Do it the right way. Cosine 2x squared x dx. So I can see that x dx over here and x dx over here are the same. And I can also see that 2x squared is what I have is equal to u. So now what I have is the integral, or the antiderivative, cosine u du. Actually, I take that back. It's cosine u 1/4 du, because x dx is equal to 1/4 du. Well, I can take my 1/4 and pull it through the integral. So I have 1/4 the integral cosine u du. And I know that the antiderivative of cosine is sine. So this is equal to 1/4 sine u plus c. See, once I do the indefinite integral, I get rid of the integral sign, and I just have the, what is the antiderivative? So it's 1/4 sine u plus c. And then my final step is to take my u again and resubstitute it, hence the name u substitution, and I get 1/4 sine 2x squared plus c. And that's my answer.